Hello everyone. In this video, let's discuss how to search an element in binary search tree. Given a binary search tree, search and find a value in it. We know that in binary search tree, the left subtree will contain a value less than the root node and the right subtree will contain a value which is greater than the root node. By using that, we can search that element in binary search tree very easily. For example, I'll take a value called 4. I need to check whether the value 4 is present in the binary search tree or not. First, I'll compare 4 with 6. Check whether 4 and 6 are equal. No, it is not equal. If it is not equal, I'll check my next condition, which is 4 is less than 6 or not. Yes, 4 is less than 6. If 4 is less than 6, I'll go for my left subtree, which is 2. Now, I'll compare 4 with 2. Check whether 4 and 2 are equal. No, it is not equal. If it is not equal, I'll check whether 4 is less than 2. No, 4 is also not less than 2. In that case, I'll check my next condition whether 4 is greater than 2. Yes, the value 4 is greater than 2. I'll go for my right subtree. Now, I'll take the value, I'll compare with the node value. Check whether 4 and 4 are equal. Yes, 4 and 4 are equal. In that case, I'll return the value that the element 4 is present in the binary search tree. Output, I'll be getting it as found. Now, let's take another example and find whether the element is present or not. For example, I'll take a value called 10. Okay, I need to check whether the value 10 is present in the binary search tree or not. Compare 10 with 6. 10 and 6 are not equal. So check whether 10 is less than 6. No, 10 is not less than 6. Check whether 10 is greater than 6. Yes, 10 is greater than 6. So I'll go for my right subtree. I'll go to this node now. Now compare 10 and 8 whether both are equal. No, it is not equal. Check whether 10 is less than 8. No, it is not less than 8. Check whether 10 is greater than 8. Yes, 10 is greater than 8. So in that scenario, I have to go for the right subtree. Now check 10 and 9. Check whether these two values are equal. No, it is not equal. Check whether 10 is less than 9. No, it is not less than 9. Check 10 is greater than 9. Yes, 10 is greater than 9. Try to go for the right subtree. Right subtree is null, which means that the element 10 is not present in the linked list. This is the logic for searching an element in the binary search tree. Now let's go for the program. Already I have inserted elements in the binary search tree. Now let's run and check. I'll give the size of the binary tree as 5. The elements are 1, 3, 5, 4, 2. And in order traversal 1, 2, 3, 4, 5. I have inserted my elements in binary search tree. Now I need to check whether the element is present in the binary search tree or not. Now let's go for the code. Int search. I'm declaring a variable called search and I'm getting the value to be searched in the binary search tree. After that, I'm going to get the input value from the user by using cin. After getting input value from user, I'm going to call a function which is search an element. Here I'm going to pass two arguments. One is root and the next one is the element to be searched. I'm going to pass two arguments, root and search. Now I'll define the function void search an element. I have passed two arguments, right? One is nothing but root. So I have to give struct bnode star node comma next one is to be searched, right? Let me give the same variable name search. Okay, what is the first thing I have to do? I have to check whether the search tree is, whether the binary search tree is empty or not. If node equal to null. If node is equal to null, which means that my element is not present in the binary search tree. I'm going to give a message cout element is not present. Okay, and then I can return. Next case, else if node of data is equal to the element I am searching. In that case, what can I say? The element is present. Element is present. And I can return. Next condition is if I'm searching the element which I'm going to search is less than the node of node of data. If the element which I'm going to search is less than the node of data, in that case what I have to do? I have to go for the left subtree. So I'm going to call a recursive function call for left subtree. Search an element node of left. If this condition is false, what is the next condition I'll be having? I can go for else, because I'll be having only one condition. Either it can be equal, or it can be less than, or it can be greater than. If it is greater than, what I have to do? I have to call a recursive call for the right subtree. Element node of right. That's all. Finally, I can give return. So this is the function for searching an element. I'll give recu recursive call for left subtree. I'll comment here, it will be easy for you to understand. Recursive call for right subtree. If the element is present, this will execute. If the element is not present, this is the program for searching an element in the binary search tree. Let me save the code and let me run the code. That is an error in the code. Struct. Okay, I have given capital S. It should be small s, because it is a keyword, right? And node of left search. Okay, in the function what I have done, I have passed two arguments, search and element. In the search and element function I have passed two arguments, but when I'm going for recursive call I have passed only one argument. That is the error. So I have to pass two arguments. In every recursive call I have to pass two arguments. That was the error. Now let's run the code. Yeah, there is no error in my program. I'm going to give my size of the binary search to be 5, and I'm going to give 5 elements: 1, 3, 5, 4, 2. So I have got in order traversal. Now I'm going to give an element to check whether it is present in the binary search tree or not. I'm going to give the element as 3. Element is present. Now let's run the code once again. I'm going to give the size value as 5. The elements are 1, 5, 4, 3 and 2. So it will print in order traversal. I have inserted the elements in the binary search tree. Now I'm going to give the element called 10 to check whether it is present in the binary search tree or not. The element 10 is not present in the binary search tree. So my program is correct. That's all.